We have a MacBook Pro. It's an A1398. It says no power. And from the trackpad, I can tell that it's a 2015 because of the trackpad. So the 2015s on the A1398, the Apple used the Force Touch, which is the haptic feedback type of design. In any case, the device is no power. As you know, we do not intend not to um, connect power to the device until we are sure what state the device is in. So they say we have a missing screw here. I'm using a P5 to disassemble, which is to remove the back screws. Okay, screws back screws are out. As you guys can see, this is a 2015, and one of the common ways you can also tell the 2015 design is the trackpad cable will go over the battery, unlike a case of the 1398, 2012, 2013, 2014. The trackpad cable will go under the battery, but the 2015 design will be the trackpad cable will go over the battery, and the trackpad will only be active when the device is in SO state. So in this case, the trackpad is not active. Okay, so it's a no power. The description was that the technician was replacing a battery, and then and then the device stopped coming on. We do not see any sign of liquid. So the first thing we're going to do is to check for short. Let's see if we have so our multimeter is in continuity mode. So basically continuity mode, so basically we expect to hear beep when we get a short. So our black probe on ground, and then our red probe, let's see. Okay, that is our, so let's see, our board number is going to be 80-00138. 80-00138. It's 80-00138. There we go. So what we are doing is we're checking for short using F7141 and F7140, which is on the PP bus line, and we can see that we do not have a short on that line. So that's not a short. We don't have a short on that line. So let's see our PP3V42. No, actually it's fine. So at this point we can just plug our power to it. I mean, we do not see any sign of liquid on the board, and then also we don't have a short on our PP bus because we don't have a short on our PP bus, which means there is no potential damage to the CPU because the PP bus feeds the CPU line. So we don't have a short on our PV bus, so the chances of potential damage to the device is basically less by connecting power to it. So right now, let's connect power to it. Let's see what we have. We have charger communication. Let's see, do we have voltage on our PP bus? Let's see what we have on our PP bus. 1.58. 1.58, okay. Okay, so let's just go ahead and remove the port. So 1.58, that is that indicate that we may have an issue by the ISL. So the ISL is your battery and charger IC. So let's take the board out real quick. Yes, okay. And also he needs to collect, okay. The ones you dropped yesterday, those were wrong. These are the right ones. So the ISL, it's that's your battery charger IC, and it is the primary regulator for your PP bus voltage. So the fact that we're having 1.8, 1 point something volt, so that we will be starting our troubleshooting from there. We have already checked that we do not have a short on that line, so the low voltage is not because 1 point something volts there is not because we have a short, so it's definitely because we have a problem on that circuitry. So what we want to do now is we want to take the board out and then go over to the area of our ISL, and we definitely do have PP3V42 circuitry because we saw that we have charger communication, we have LED on our charger. The LED on our charger is the PP3V42 circuitry. The PP342 rail is present to have to have the LED on the charger to function. So it's a good thing that we actually have that on. So we're not really worried about PP3V42 rail right now. So we definitely, and also PPDC in it's also present because PP3V42 it's PP3V PP bus PPDC in voltage is required to have a PP3V42. So the fact that you have PP3V42 means that you have PPDC in voltage. But what we are missing is the PP bus voltage. So the board is out. Let's put the shell on the side, and we are going to be starting. Okay, this can be the side. It's far. That is actually you can put it up. Okay, so our ISO is going to be, so let's open up the schematic. So it is a 00138. It's 0.00138. Okay, so the ISL is going to be 7, let's see, ISL is U71,000, U71,000. Okay, so here it says DC in and battery connectors. So DC in and battery connector. So um, DC in and battery connector. So we're going to, let's check that again. This, and then, yeah, so sorry, PP bus supply and battery charger. Sorry, so that was a different page. So it says PP bus supply and battery charger. And then by the way, by default, your battery supplies and PP bus voltage is by default. So okay, yeah, we'll talk about that in some other time because it's going to get mixed up right now. So PB bus, so this is our PB bus is generated from our ISO, and right now we do not have PB bus voltage. So we are going to start our troubleshooting from B7100. So B7100 is going to be on the other side of the board. This guy here, B7100, it's this guy here. So flip the board over. And then you guys can see what we have here. This is a section of B7100. We are definitely having some kind of corrosion here. So let us see what is it, what is there. So we have so we have R7110. It's a PV3V3 underscore G38, and that's the charger reset L. And then the other one is SMC reset L and charger reset L. We are definitely not having an issue with the charger reset L because we have LED on our charger. If the state was, if charger reset L was low, we would have, and if the SMC reset L signal was low, we would be having a situation where there will be no LED on the charger. But in this case, we do. However, this here, charger reset L, let's see that. Okay, and then the other one, what is this? Okay, so let's get another board. As we can clearly see, we have an issue here. Yeah, so this two needs to go. So this was basically this was very much like a coincidence because you would think that because a battery was replaced and then this is the ISL plays a role in the battery communication. You would think, oh, maybe there was an issue from the battery, but in this case, this is not what it is. Okay, okay. So we are going to clean that up. Let's see, that pad seemed to be. Ah, okay. So what we're going to do? This pad seemed to be missing, but then we do have. So what we are going to do? This resistor here, we may be crossing the resistor this way instead of this way. I don't know if you understand. So we need PP342, and then the pad by the PP342 seem to be missing here. This pad seems to be missing, but then there's a connection here of PP342. So when we install this resistor here, instead of having to flip it straight, we'll flip it like this. So as you see, that pad is missing. So the pad here is missing. So yeah, that's what you're gonna do. So we'll be flipping the resistor the other way. Let's get a donor board. So actually, R7102 it's a no stuff, and that's because yeah, that's because charger reset L, the work of charger reset L is going to be done by this here, and yeah, let me see. Wait, what if? No, wait. So let's see. Yeah, R7102, it's going to be a no stuff. Let's just confirm that. I mean, we can see this is a donor board here, and we can see that way. Could it be that it was removed? Let's see if it's a no stop. R7102. Let's see. R7102. R7102. Is that a no stuff? Yeah, it's a no stuff. So it means there's nothing there. So it's not populated. So there's nothing there. So the other one, so it's just going to be this guy here. Okay, so let's replace. So which means we only have to replace that. Okay, so just we only need to, and also yeah, we also need to replace this cap here. It doesn't look so good. Okay. So also slightly reflowing the ISO. Okay. So we know we are supposed to have PP3V4 to PP3V4 3.4 volt here. We know we're supposed to have 3.4 volt here. This should be around about 4 volt or so. Uh, uh, I think the charger cell should be around about 4 volt for MacBook Air, and uh, if my memory serves me right. Okay, well, that's not relevant right now. Let's see what voltages we have, and obviously also we want to see if we now have PP bus. So I'm not gonna. I don't want the fans to do the telling for me because I usually do not cannot handle that, and that that part of waiting for the fan to respond. Okay, so we definitely have. I mean, we had this before, which is the LED on the charger. So what we want to do is we want to see what we have now on our PP bus. By the way, let's go to that section of the board. And PP3V4. Okay, so let's see what do we have here. 3.3 volt. That's fine. And then the top of the resistor, 3.3. That's fine. 3.3. That's fine. 3.4. That's fine. That's fine. Let's see what we have on our PP bus. And now PP bus is 12.6. Okay, that's beautiful. We now have a working machine. So 12.6 means that our device, it's definitely doing its thing, and which is our device is starting. So I'm going to connect the fans now. We should see a fan spin. Okay. And by the way, this is a 2015 board, so the fans will be, so the fans reaction is going to vary from the 2014 and below. So but what I want to see is let's see if we have 5 volt, if we are in SO state. Let's see what voltage we have here. uh, don't seem to get anything there. Wait, what's happening? Wait, we just got 12.6 and now we have 1 point. Could it be that our ISL has failed? Let's check that again. 1.6. I mean, we just now we had 12.6 and now we have 1 point something volt. Okay, so let's just go ahead and replace our ISL. So uh, yeah, let's replace the ISL first. Okay, let's get a. Let's hope the ISL from this board it's fine. So when he brings those screens, so one of the screens is what you install for Anthony. Yeah. So also the orientation is the same, so I don't have to worry about the orientation. Okay. Give it a bit of time to cool off. And then another thing, the part here that is missing, which is even though it's not, this is not populated, that would have been a concern if that was, say, a connecting type of part to another component that is populated. But in this case, that's a PP342 line, and we have PP342 present in this section of the board. So it's nothing to actually worry about here. So yeah, just nothing to worry about here. And yeah, so we have another ISL installed. Let's see if we have anything different. And then again, what I want to do is I want to disconnect the fans because I don't want to be hoping for fan spin. I want the multimeter to do detailing for me. Let's see. Okay, that's good. So let's see, what do we have on PP bus? 12.50. Okay, so that's seem very good. That's PP bus being present. Now let's connect our fans. Uh, okay, let's see. What do we have now? Okay, so we definitely, yeah, we're getting fan spin. So there was no need for, I mean, the fact that we have fan spin definitely means that we will have a previous voltage, which is at 12.59. That's beautiful. The next thing we want to do is we want to clean that section of the board and then see if we actually have, yes, we have fan spin, but we further need to confirm if we have a working device. First of all, clean that section of the board. Okay, let's see if we have uh, see if we have something on our screen. We are also going to plug in the SSD just so that we can get to see an Apple logo. Though we're not really going to wait for the device to boot to desktop. We just want to see if we get an Apple logo. So we have the SSD connected. We have the screen cable connected for the screen. And then we want to see if we have Apple logo. Okay, we're getting fine spans. Yes, and that it's a beautiful Apple logo. Okay, um, this is yeah, this is exactly what we want to see, and that's beautiful. So we have so I would say we had failed ISL. and yeah, it's just funny because we had a bit of a corrosion in that section of the board, and then we thought maybe that was the case, but the section that was corroded is actually a no stuff, and so it could really be said that the battery kind of killed the ISL. That's a possibility. No, it could be that the battery killed the ISL. I mean, that's because we did a slight a reflow on the ISL, which was, and then it picked up again, but that's like a temporary thing, and then it died again. So, well, we had to replace it, and that works. So, thank you guys. I will see you guys in the next video. This is the successful repair. This is now going to go to Peter, and then he will take over from there. He's going to assemble the device, do the necessary test, and then this can be the ticket can be closed. Thank you guys. I'll see you guys in the next.